Jack, would you like to present? Jack, would you like to present first, or Shengfeng, would you like to go first?
I'm flexible, whatever's easiest.
Okay, so let's go with Jack. And um, Jack is an aspiring tunnel engineer and is currently pursuing his master's in the Geosystems Engineering program at UC Berkeley, not too far away from where I am right now. He has a Bachelor of Science in Civil Engineering from UIUC, where he was a part of um, extensive research in the field of underground construction and has served as a co-author on several of technical publications. He comes with an interesting background, has shown interest in data science and artificial intelligence, and yeah, let's get to know more about Jack and uh, what his path to tunneling been like.
All right, so thank you to the Youngers Members Committee for hosting this. And this is kind of my past 4 years summarized in 10 minutes. So I started out my undergrad at the University of Illinois. I got very lucky with the way I planned my coursework, so I managed to get out of there in 3 years. But I'm just kind of go through some of the extracurriculars and research experiences that influenced my perspective on tunneling now. So one of my first initiatives was with ASCE, and ASCE hosts 20 regional student conferences. They're very prominent amongst the undergraduate community. And I was in charge of one for the Midwest called the Western Great Lakes. And that was a year-long planning process in 2022 where I raised $60,000, and then I ended up hosting a 3-day conference for about 20 schools and 500 students. But one of my coolest accomplishments was that I managed to get the head of the Army Corps of Engineers to serve as our keynote speaker. So that's him on the bottom right. And it also helped that he was an Illinois alum. And here's some photos from that event. So that was kind of a nice little introduction to civil engineering. And at the same time, I was also involved with our school's concrete canoe team. I was the mixed design captain, which is the most stressful role because you're always biting your teeth on the sidelines, hoping your canoe will float. But I have some photos here from when I was in the lab and paddling out on the lake. So I was involved with a lot of technical initiatives. Illinois has the first concrete canoe team in the United States. So we always try to be ahead of the pack. But one of our new projects was to design a GPS tracker. So one of the people on the team, their relative was the creator of Apple's Shortcuts app, which is installed by default on every iPhone. And they created the hardware for our GPS tracker. And then I ended up creating some visualization software that you can see on the right here, which we use for training purposes. So then I kind of started shifting more towards geotechnical engineering. I was the president of our geotechnical engineering club called GSO. So to my knowledge, we're the only one that has a UCA, DFI, and Geo Institute student chapter. And I'll kind of touch on the UCA stuff at the end, obviously, because this is the UCA program. But one of our other major initiatives was our GeoWall team. So in that role, I raised $30,000 to send our GeoWall team to nationals. And if you don't know what GeoWall is, essentially you design a box, which you can see on the bottom right, and the front face, which has been removed from one of the photos, holds back sand, and you're essentially evaluated on how much deflection there is in your retaining wall and how long it can survive. And then we also built a numerical model that you can kind of see on the right there. So I've also tried to really stay involved with the Geo Institute because I'm more of a multidisciplinary geotechnical engineer. I'm not just solely focused on tunneling. And recently I interviewed Professor Andrew Whittle of MIT for Geostrata, which is the main magazine at the Geo Institute. You can kind of see the cover on the left. Shameless plug, so you can all read that in the upcoming issue. I also currently serve as the grants committee on their essentially national student body. And then I was also interviewed by Brad Keeler, who's the executive director of the Geo Institute, on his podcast for my GeoWall efforts. So I'll just kind of quickly skip through. All right, now for the tunneling section. So I was a undergraduate research assistant with Professor Yusuf Ashash, and he has a lot of stuff going on, but our main project had to do with the 2028 Summer Olympics in LA. So obviously LA Metro is building 3 new tunnels there as part of their 28 by 28 infrastructure initiative. And we received data from LA Metro, and we ended up researching AI and deep learning models, which were capable of predicting settlement across any given stretch of tunnel and geology across any given stretch. Now, I know this is kind of a hot topic in the academic community. There are a lot of groups working on this. But our team was backed by the National Science Foundation, and we collaborated with UC Irvine and California State University Long Beach. So I'm under NDA, so everything I've pulled is from the public domain. The next few screenshots I'm about to show you are from a presentation that Professor Ashash gave at the Rock Science International Conference. So this is an artificial neural network. We tested a lot of deep learning models, but we ended up going for a relatively simple AI model. And if you're not really rehearsed in AI, artificial neural networks are supposed to model the human brain. So I'll just pull out my laser pointer here. So these are data points from the tunnel boring machine, or from one of the tunnel boring machines for the Crenshaw K line. And then they're passed through these neurons, quote unquote, and this kind of processes the data. And then eventually you end up with a prediction for settlement. So this was our primary structure as of the time I left the group. I'm sure they've changed things around since then. And then these were our results at the time. So again, this is for the K line. And this top image is the alignment. And then the second image here is predicted settlement. So if the orange dots line up exactly over the blue dots, it means we got it correct. If they don't, maybe we're a little bit off. And obviously you can't expect to be perfect on every prediction, but I think we did an okay job for our work at the time. And then our bottom image here is the geology predictions. So the top line here is the actual geology or predominant geology along the alignment at that specific time. And then this bottom line here is the predicted geology. And the colors match up. So again, the bottom line is that we managed to do an okay job. And as far as I know, after I left the group, they're now working on trying to make it a more general AI model. So if you have data, for example, from one line of LA Metro, how can we use that data to predict other data points from other lines on LA Metro? And as I said earlier, there are a lot of people working on this type of technology. So how did we differ? Well, we looked at it more from an empirical perspective at first, and we were trying to compare how do empirical models perform to AI models. And Illinois has a long history of this. I'm sure people have heard quite a bit of Ralph Peck's engineering judgment quote. So we were kind of continuing that legacy, so to say. And then we have a few papers on this that you can read if you're interested. Ultimately, I always get the question, where is this technology going to be useful? Where is this going? In my opinion, you're going to start seeing a lot more autonomous underground construction technology. So, for example, this was a prominent news article the last few months with Australia launching their first autonomous TBM for the Sydney Metro. So that was my research. I also completed a few internships while I was at Illinois. I was first at Mott McDonald's in a general consultancy type of environment. Then I went to Keller for some contractor experience in general geotech, so that wasn't so much tunneling. And then I ended back off at Mott McDonald for some tunnels engineering consultancy work. Then I seem to have gotten pretty lucky because Berkeley said, why don't you come out and study with us for a year and we'll pay for everything. So I said, okay, I'll come do that. And these are just some photos from my experiences so far. Obviously, it's pretty sunny in these photos, but it isn't quite so sunny today. And these bottom photos are some of the field trips we've been on. So this one on the left isn't actually a tunnel. This is inside of a dam. which is this one. So that was pretty cool. And then we've also been to landslides. We've been out doing field testing. We've had geology field trips in the Sierra Nevada mountains. It's a really fun program, and it's really giving a broad, diverse background, because I think it's important to be able to speak general geotech and tunneling at the same time. So where do I want to go? Ultimately, I want to work at the intersection of computing and tunneling. I'm interested in big data, high performance computing, AI, all that good stuff. But kind of the key word is I also want to be working towards my PE license. So that means being billable and doing more traditional tunneling work as well. And how does all of this tie into UCA? So I was lucky enough to be selected to be a scholarship recipient for RTC in 2021 and 2023. I don't have any photos of me there, unfortunately, but I did take some pretty nice photos of the city. It was a wonderful experience, and I'm very happy that UCI is definitely one of the most generous organizations I've been involved with. None of the other organizations I'm involved with pay nearly as much to attend their conferences, and it's really nice to be able to network with everyone. So when I was leading the UCA student chapter at Illinois, these were a few things we struggled with from a student perspective, but I'm hoping to maybe kind of change as I get involved with the industry and hopefully get involved with UCA in the future. But we had trouble recruiting people at times because they aren't always aware of UCA, even if they're in geotech. And some students who engaged with our club had little to no interest in underground construction, and they were just trying to go for a cash grab type of situation. And we also noticed that faculty and programs are starting to increasingly engage with the Geo Institute in a tumbling capacity, which was a little bit tricky because we ended up in a competition scenario, right? And then we also had issues connecting with student chapters across the United States because there's only 3, and now only 2 are active because the Illinois one has kind of fallen out. And we also had trouble recruiting people with the $5 membership fee. But this isn't to complain. This is more to say things I kind of want to change if I were ever to get involved with some of these committees. But I've noticed that starting to build connections with the academic programs is particularly helpful. So if you're an alumni, telling current students or current professors about UCA has been particularly helpful, I've noticed. Student competitions for other organizations have been great. So DFI and AC, they're wildly successful with their student competitions, and maybe it would be great to offer something in a UCA capacity. Likewise, in-person events are quite successful for them. And site visits are effective, I will concede, but they only really work for major cities because if you have to travel 4 or 5 hours at a high cost, it can be a little bit tricky to organize people to go on such a trip. But yeah, these are initiatives that hopefully I'd like to pursue one day. And that was basically my past 4 years in 10 minutes.
Thanks, Jack. Um, pretty good presentation and pretty strong presentation in terms of the kind of work you have done as an undergraduate student. And um, not many undergraduate students get the opportunities to work on such complex topics. But happy you got the chance, and also happy that you had the opportunity to attend the 2 tunneling conferences. So yeah, no, great perspective of what the UCA student chapters are struggling with, and yeah, your inputs are really appreciated, and we would like to get a few more inputs. We can chat about that offline as and when you get more involved with the UCAYM and the rest of the committees. So no, pretty great. Thank you. People on the call, the attendees, do you have any questions for Jack? Jack is finishing up in May of this year and is looking for full-time opportunities at the intersection of computation and tunneling. And I think that is the future. When you talked about autonomous TBMs and settlement prediction and TBM performance prediction. I think that's where the industry is slowly heading to. And that includes geohazards prediction as well. If no more questions, we'll move to Shengfeng. Shengfeng is in his third year of PhD and is going to defend his proposal this Friday. So good luck for that. And Shengfeng specializes in geotechnical engineering with an emphasis on TBM performance prediction. He is a student at the Stevens Institute of Technology and is working under the guidance of Professor Rita. Shengfeng's involvement extends to a detailed analysis of probable hazards on the $12.3 billion Hudson Tunnel project that was conducted in collaboration with NJIT and MIT, and I think that's a stellar achievement, Shengfeng. His academic contributions include several publications. He has a master's degree from China, and he has been a recipient of the UCA Young Member Scholarships at RETC and at the Cutting Edge, and also the GA Institute Scholarship. Shengfeng, the floor is yours.
Thank you, Roger. Thank you for the UCA for this, great opportunities to present my, some completed research. So my topic I want to talk about today is, some part of my dissertations. This is the beyond the tunnel vision and leveraging machine learning techniques for the predictive analysis of tunnel boring machine performance. So a little bit about me. I got my bachelor and master degree back in Fuzhou University in China. Both majors are geological engineering. And now I'm pursuing my PhD degree in Stevens Institute of Technology. And my main research regarding about the slope stability, basement excavation, and my current research is more about the tunneling and the machine learning application. So I will give 3 parts about my research. The first one is even an overview about some introduction and the literature review, and the second part I want to talk about generalization capability and assessment of machine learning models in TBM performance prediction. And then I would introduce about incremental learning strategy to improve machine learning model generalization. So we can see there are many traffic jams in big cities, and where civil engineering are started to explore the underground space. And in this circumstance, the TBM has become a very popular way to explore the underground space. So to ensure the safety and the cost-effective construction of TBM, the predictions of TBM performance can be important. And the machine learning model actually provide a very good way to process the vast volume of data and has very good capability to capture the nonlinear relationship and high accuracy. So generally, I think there are 3 phases of machine learning application. The first phase is just to explore the potential application of different algorithms. And the second phase is to enhance the model's performance. Now the current state is to develop models that have greater practical applicability and real-world utility skill. So even though we have many researchers about it, they still have a long way to go toward the tunneling automation. So the first one I think is most of the models are developed based on just one project, and they cannot perform very well when applied to a new projects. The second thing is the the model cannot capture and integrate the involving knowledge from ongoing projects. And the third thing is they cannot predict some extreme conditions, which may be very important for tunneling excavation process. So for the first goal, I want to research is about when you get the data from the tunnel one and you use it to build a model, you can get a very good performance. But when you apply this kind of model into another project, which is the tunnel two, then you don't know how the model will perform. So my first goal is to assess the machine learning models generalization performance here. So the second thing is, well, when you generalize to a new project, you cannot expect the model to perform very well. So like in here, if you develop a model for using the data from a tunneling in rock, you can have a good prediction for the tunneling in rock. But if it comes to the tunneling in soil, then you don't know what you will perform. So the second goal of my research is would talk about the continuous learning of the new knowledge gained from the ongoing project. So the third thing is, well, we may have many extreme values. Commonly, many researchers would remove this kind of data because they think these data points can be regarded as outliers. But in real projects, these projects may indicate the dramatic geological change and maybe some potential risks. So my third goal would be to research how to handling this kind of imbalanced data. So in this presentation, I would talk about mostly the first and the second goals. So so for the generalization ability assessment, I'm very lucky to have these two projects in the same cities. So the green line represents the line C and the red line represents the lines. They share the similar geological conditions and the similar construction methods and with some similar physical parameters. So this is a good chance to test the generalization ability. And you can see from here, generally we have very similar geologies for these both two projects. And for the model development, I used 9 features to predict the penetration rate. So through this analysis, I will generally keep the PR values less than 125. So this is the process I developed my research. I investigated the influence of both the splitting and the scaling techniques on the model's performance and the generalization. Then I choose these 6 popular models here and then generalize to the whole data of line is tunnel. I would use the R-square and the RMSE, root mean square error, to evaluate the performance of the model. So generally, I would have 6 different combinations of splitting and the scaling techniques. So so these 2 plots shows the training and the testing performance of these 6 models. Generally, you can see from that the models are more easily influenced by splitting technique than the scaling technique. And in testing, the random split actually continuously outperform the stratified split. I think this may be arisen because of the imbalanced data. So if the random split in allocate more skewed data into the training, I think, of course, the model will perform well. But still here, I would choose the stratified split. I think stratified split will allocate lower proportion of data points in this range for training compared to that of random split. So this technique can provide a more comprehensive presentation of the data, which can help mitigate the risk of overfitting to specific class. And additionally, I think the stratified split can ensure that the test set is representative for the overall data set, which is critical for evaluating the model's performance in real world scenario. So this is the generalization performance for the first three model. You can see that the R-square can be negative, which imply inadequate generalization performance by the model, and also in some cases the R-squares can be positive from 0.019 to 0.405. And for the random forest, similarly, we can see in some cases the R-squares can also be negative, but in some cases the R-squares can be quite decent. Also, for the last two models, the CARD and the XGBoost, actually shows the consistent and bad performance for all cases. So for the R-square of XGBoost, it shows from 0.603 to 0.7, and for the CARD, it can show from 0.6 to 0.687. So these two models actually, seems less sensitive to the choice of splitting and scaling technique. So we would choose the XGBoost as the base model, and since it's less sensitive to the scaling technique, I will choose the stratified split for the following research. So for the key findings here is these models actually are more easily influenced by splitting technique in imbalanced data, and for this ensemble algorithms like the random forest and XGBoost actually demonstrate more robust against data variance. And for the generalization ability, actually, the CARD and XGBoost shows consistent bad performance across different scenarios. So, so how to improve the model's generalization ability? I have tried to use the incremental learning to improve it. So for the data in lines, I divided chronologically into 3 equal segments here. For the following research, I would do the incremental learning. First, I would combine the line S with the first 3 source data of line S data to update the model and then test the generalization ability in the rest of 2 sources of data. And then I also combine the line C data with the first 2 sources, line S data, and test the generalization ability in the rest of 1 set of line S data. Also, for the comparison, I used solely the line S data to train the model and test it. So the other thing here is when we plot all the features versus the penetration rate, we can see 2 different distinct trends here. One is the PR less than 25 millimeter per rotation, and the other one is larger than that. So later we would also investigate how the model generalizes in two distinct behaviors. So we can see from this plot, the first, the up3 plots are actually the performance of the model we built, and the bottom 3 is the generalization abilities we tested in the rest of LINE-S data, and the red 2 is the model built only on LINE-S data. So we can see the model's performance are generally good, but when we incorporate the first 1/3 the LINE-S data, the performance actually improved. But well, when it comes to the second incorporation, actually the R square decreased a little bit, but it doesn't mean that the generalization ability is not good, because when we check about the RMSE, we can see that the RMSE also decreased more. So it means the tested data actually revolved more around y equals to x. So so for the comparison, we can see the performance is really bad. I think that's because in the first third of LINE-S data, actually there is no PR values beyond 10. So when you tested on the data beyond that range, the performance were really bad. And well, for better vision, I actually plot the magnify this plot into 0 to 25. So we can see in the first plot, actually almost all the data points are overestimate the performance. But when you incorporate the LINE-S data, the results does make more sense. This is for the performance for the model built only on LINE-S data. Actually, the performance actually more or underestimated the test performance. Okay, so so when I test the models on PR only smaller than 25 millimeter per rotation, actually the performance still are very good, but we can see the generalization ability keep improving. So we can also see from this R square and RMSE values. When we test it using the LINE-S data only, we can see actually this incremental strategy also help improve the model's performance. So we also test the model's generalization ability only within the range from 25 to 125, but the model's performance can be fairly well, but well, the generalization the data for generalization assessment is quite small, so we cannot make more conclusions for here. Okay, so after that, we also investigate the influence of incremental size. So this two plots represents the incremental learning performance for the XG burst on both the penetration rate smaller than 125 and smaller than 25. So we can see some fluctuations here, and I think one reason for these fluctuations maybe the increasing skewness of the data for training, and the other reason could be the catastrophic forgetting. Catastrophic forgetting means when the new data coming for training the model, actually the structures storing this kind of information would change. So would change to fit this new data, new information, and the model may perform worse than the previous model on the previous learned task. So sometimes the catastrophic may be more pronounced in the second model. I think for the second model, only on the penetration rate smaller than 25 millimeter per rotation, the model tends to exhibit simpler structure compared to imbalanced data. This simply can make it more vulnerable to forgetting when new data is introduced. So this kind of model may need a more dramatic change to fitting the new data. So that's why the second model may be more, the phenomena in the second model may be more evident. So this is the generalization performance of XGBoost on penetration rate smaller than 125. The dashed line represents the R square, and the solid line represents the RMSE. So we can see that actually in the first 200, these values keep relatively stable, but after that it has a very dramatic change in both the R square and the RMSE and the LEM. The R square will keep decreasing, and the RMSE would increase a little bit. So this dramatic change will be attributed to the fact that it incorporate more skilled data into the training process, so that it can perform better for the rest of data. And this is the generalization performance on penetration rate smaller than 25 millimeter per rotation. So we can see for more balanced data, the model's performance and the generalization ability actually will keep improving along the process. So the key findings of this is, well, segmenting the data based on these penetration rate ranges and the model is distinct trends can be very effective, and the integration of nice data could bring a potential improvement to the model's performance when compared to the models built solely on line S. And the XGBoost generally demonstrated strong performance for the training and the testing. And the last one is the incremental learning actually has the potential to improve the model generalization. But the presence of the skilled data could sometimes hugely impact the model's performance. So that's all my presentation. Thank you everyone for listening.
Thank you, Shengfeng. That was really interesting presentation, especially the part of predicting the penetration rate. Is that the only major parameter that you looked into for predictions, or?
Yes, currently I focus on the penetration rate prediction.
Okay. From the attendees, do we have any questions for Shengfeng? Any points of discussion, any insights?
Yeah, I actually have a question for Shengfeng and for Jack.
Yeah.
So for both of you, When I first got introduced into AI, it was actually via the route of neuroscience, right? So there's a bunch of good books out there by neuroscientists that kind of talk about the replication, the neural network, the dendritic system, and all that. So could you give us, and to those who aren't very familiar, your favorite, book or piece of paper that talks about AI and kind of that introduction to, deep learning?
You mean the machine learning or and the deep learning for the
Anything related to that topic? Yeah.
did you mean the theory or applications of the in the tunnel?
Very broad. Let's start with the fundamentals,
Oh,
right?
okay,
Like,
okay.
yeah. Mm-hmm.
Mm-hmm. I don't know the machine learning because I take the machine learning course, but I don't look into the papers specifically because for me it's a little easier for that. But for
Right.
the deep learning, I think sorry, let me see the name of the
Yeah.
like
I'm
there is a very famous professors here. I always take his course on Coursera.
Mm-hmm.
And Andrew Ng. Yeah, this professor.
Perfect. Jack?
I'm gonna have to give a cop out here. And I'm just gonna say that the most interesting thing I'm looking at now in AI is something called NERFs.
Mm-hmm.
And from these things, you can create these 3D scenes just from a series of photos.
Oh,
So
wow.
so this was about like 50 photos of the College of Chemistry sign here at Berkeley. And I don't know, I just think it's a super cool technology. Maybe it has applications in tunneling, maybe it doesn't. We'll have to find out.
That's phenomenal. Yeah. Appreciate it.
Yeah, this technique is a little similar to the digital twins.
Any more questions? Well, that is it then. Thank you.